So you have m or m bracket. So substitute x double dot dot p and xp into the characteristic equation. Okay. So when that's the case, you have what? I'm going to copy all this. I'm going to copy all this. I'm going to paste here. And then I'm going to copy this. And then I'm going to paste here. Okay. So we know, okay, we're going to substitute everything into a characteristic equation. So you have m bracket minus x omega naught squared sine omega naught t bracket. And then you have what? You have your plus k bracket x sine omega naught t, and then this is equal to 7 or f naught sine omega naught t. Okay, and then now you can take out your what? You can, did I miss anything? You can take out your sine omega naught t, right? You can take out your sine omega naught t, good, minus x omega naught squared m plus by kx, and this will be equal to what? This will be equal to f naught sine omega naught t. Okay. So now you can get rid of this. You can get rid of this. You have minus x omega naught squared m plus by xk. This is equal to your f naught. We take out our x is equal to k minus by what? Minus by omega naught squared m, and this is equal to f naught. Now, at the end of the day, what are we trying to achieve? At the end of the day, we are trying to achieve x as a function of time is equal to c1 cos omega t plus by c2. So for this case, because it's undamped, okay, omega t plus by c2 sine omega t, we want to plus by this x term. This x corresponds to that x over there. Okay? And we know that x over there has to be in terms of what? Has to be in terms of meter. For now, it is not equal to what? Meter. So how to get the right-hand side to be equal to meter? So remember, we have F naught. This is in what? Newton, right? We want it to be equal to what? Meter. So we need to divide by what? Divide by K. Am I right? We have to divide by K. So when we divide by K, then this will be equal to what? This will be equal to Newton per meter. Then it's equal to meter. Okay. So we have to find X. Okay. So what I'm going to do is I'm going to take out K. X, K, I'm going to take out. I have 1 minus by omega naught square m over K, right? And then this will be equal to what? F naught. Okay. So from here, X bracket 1 minus omega naught squared m over k. This is equal to f naught over what? F naught over k, right? And then note that omega n is equal to square root k over m. So for this case, x bracket 1 minus by omega naught squared over omega n squared bracket, this is equal to f naught over k. So x is equal to f naught over k divided by 1 minus omega naught squared over omega n squared. Yes. Yeah, you can, but tendency of mistake is higher. It's better to do this. Now, you can avoid all this. Okay. You can avoid all this. What must you do? Okay. How do you avoid all these steps? I cannot remember all this. You guys are young. If you can remember this function over here, okay, if you can remember this function over here, just write it out. Are we clear? I'm not, there will be no marks in what? Deriving. Okay, I repeat again, there will be no mark in what? Deriving. But if you cannot remember, what do? You derive. If you can remember, you're good to go. For me, if you ask me what's my option, I'll try to remember, but if I can't, I will derive. If I'm not sure, I will check. Yeah. Yeah, there's a sign. Okay. So from here, we know that x as a function of time is equal to C1 cos omega nt plus by C2 sine omega nt plus by f naught over k divided by bracket 1 minus omega naught squared over omega n squared sine omega naught t. You're good to go. By the way, you can see my table. There are no notes, nothing. I was panicking because at this stage down here, I don't know what to do when I realized that on the right hand side is not what? It's meters. I was like shitting myself out everything. Okay. Are we clear? So just be right out. Okay. Don't remember. If you remember right, the next day you forget what you have learned. Understand the concept, please. Okay. Yeah.
Question by rewriting your answer as the date x not like k and then rounds x plus the basically this conversation given the question and just stand it out the same rate even on the question.
Can you slow down, please? There's a lot of layers. Oh, the characteristic equation. Oh, where's the characteristic equation? Yeah, wait. You mean this one? Yep. Yep. So for this question, it's a force. It is displacement. You have to be really, really careful. So before I answer your question, are you all okay with how you should answer this question? Yes or no? Is it clear? Right? If you cannot memorize, you write. Okay, any question regarding this? Are you okay with this? Yes. You got the same answer or no? You got the same answer, don't frighten me, okay? Okay, this answer is given by the textbook. I'm not saying that the textbook is perfect. The textbook can also be wrong. Okay, later on, you get the same answer, right? Okay. Let's go. Can I go into question number 2 to answer you? Okay. So for question number 2, you have to be really, really careful with this. Okay. So for question number 2, right? So if we were to look at question number 2, right? I picked this question deliberately, by the way, okay? Okay, so again, they state that the spring mass mechanical system, when they state there is the spring mass mechanical system, basically there's no damper. The damper is out. So we know that this is another problem that you have this. Spring mass damper. Now, at this stage, they say they are going to induce, so you have a K, you have an M, you have a deflection, okay, which is equal to delta naught sine omega naught T. So for this case, if we look at forces, okay, if we write M d squared x, then let me zoom in, over dt squared plus by kx. And if you just write delta naught sine omega naught T, what's the problem now? We know that this is in Newton, this is in Newton, this is in what? Meters. So it's wrong. So the only way to correct this is to how to get what do you have on hand now. So you sit down like, oh crap, what do I have now in hand? That if left hand side is equal to Newton, right hand side has to be also equal to what? Newton. Yes or no? So in this, you know that we know that deflection is in meter. So the only way is we know that K is equal to Newton per what? Meter. Yes or no? The only way to get this into meters, right? If you have a meter down here, so if you have K delta is equal to Newton per meter multiplied by meter, cancel. So that's why you include a what? For that reason only, the units have to be balanced. You cannot do anything else. I don't know what to put else beside that. Yes, sir. Mathematically, yes. Physically, don't mean anything. Mathematically, you are absolute. That's why you have to be really, really careful. You know, in math, you can have time function is what? Time magnitude equal to minus. Remember what I told you? How is it possible when time magnitude is equal to minus? Back to the future. Not possible. Okay. So for question number 2, you have to be really, really what? Cautious. Are we clear? Okay. Anyone regarding question number 2? Question number 2 is not that bad. The only why I put it there is I want you to see, right? The function over here. This is what we call a force displacement. Not necessarily a force. Okay, it's a displacement. Okay, not a force, but a force displacement. You want it to oscillate at that magnitude. That's the only difference. Okay, so be very cautious about your unit balancing. We clear? Okay. So that is question number 2 in a nutshell. Yes. That's okay.